hello volleyballers. And poor old Ed, we're missing you as well. So if we haven't actually hit exercise AF, we need to make sure that we've got this stuff under control. So this all came from Pascal's triangle. They're summarizing it, and it's basically a shortcut to help you expand big old brackets. Okay, and then this one here is a nice formula. You could have found it yourselves when you were discovering, but this is to find a particular term of an expansion. All right, so we'll do, I think the best way is if to just dive straight in and do a question, and we've got most people who are up to question 6, but yes, volleyballs, we will just remind you, I know there's a heap of examples there, but we can do, so those who have done, what one would you suggest was a good one as a great example? 2, 1 and 2. He said 8. I said out of 1 and 2. Okay, so they suggested 1C to CC, Senor. Now, volleyballers who are not here, people who have been missing in action, you all know, good old Pascal's triangle. You haven't seen it, but I'm holding up a dog. That's the mascot now. Pascal, the mascot dog. So not a real dog. We've done this a few times, so we've got our Pascal's triangle. 1, 2, 1, 1, 3, 3, 1. And how does this link in with the combination stuff that we've been doing? Remind me. Pardon? The what? Yep, the coefficient constant things in front. Yep. So how do, instead of having to do Pascal's triangle, so I don't want to go up to 20 rows. So how does the combination stuff help us? Yeah? So this one, what would this one be? 4. What would I have to type into my calc to actually get that value? Using the combinations. Yeah, so this one is C4 1, this is C4 0, this is C4 2, this is C4 3, and this is C4 4. And if you think about it, all right, C4 1, you're saying how many ways could we choose one person from a group of 4? Well, does it make sense? There's 4 ways because there's 4 different people. Oui? And a reminder, how do we get it on our calculator? Oh, look, it's already there, but how do we pull it up? Morgs, do you remember how to get your C? Option? More. Prob. And so then if we went for C1, boom. So now we don't have to do Pascal's triangle all the time. We can just use our calc. Happy with that? Excellent. So now it comes time and they say, let's expand this one here. I love the fact that it says do not simplify. So we use our beautiful formula, which I've just erased from the top there. But, whoop, okay, they actually haven't got one here, but I am going to say ours is technically, this is C. What would be your first doodad? Actually be C, 20, 0, yes, which is 1. But I'm just putting it there so it fits the pattern. Oui? And the pattern is saying take your first term, so here's A, take your first term and it goes to the power that you have. There is no B. What happened to the B? It's actually to the power of 0, and we know anything to the power of 0 is uno. Uno, dos, tres, cinco, 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 seis. So we're going to say that's 2x to the 20, and then it's minus 3 over x to the 0, which is just 1. Happy? Remember, we're doing this for the volleyballers and Ed, who are going to come back from camp, and the first thing they're going to do is want to do their maths. I hear you laughing, Sask. Right? And then we want to do our next term. So again, that's going to be 2x, but now we take 1 away from the power. Yeah? Or you can go, it's 20, take 1, so we get 19. We happy? And then the next term will be, don't ignore your minus, so that's going to be minus 3 over x to the what power? It's to the 1, and you know that for 2 reasons, possibly 3. Right? 1, we're following the rule here. So n take 1, and then this is actually your r. Okay? What's the other reason we know that it should be 1 if we're not following that rule? Yeah, the powers have to add up to the n. What's another reason why it should be 1? Following the pattern, that would have been 0, this would have been 1. Okay, next, plus, it would be C22, and then 2x. 20 take 2 is 18, or you're just following the pattern, and then it's minus 3 over x. Again, following the pattern, I tend to go 18 plus 2 is 2, or you're saying it's that one there. Happy days? Write down the first 3 and the last 3 terms. Oh, the last 2 terms. Oops. Okay, so we've got the first 3 terms. I'm going to go, this will go dot, 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 plus, what would be the very last term? Alex, look like you're listening. The very last term would be, C2020, blah, blah, blah. And the second to last term would be 2019. Now, what, if anything, can you tell me about this and this? They're the same, right? And what is the same value? What are they? It'll be 1 on the outside. Round the outside, round the outside. Brody said 20. He's way off today. Brody did not say 20. He said 0. That's even worse. Right, what about this one? 19 from 20. What one does that correspond with? Yeah, they would be the same. And yes, that would be 20. You can check it on your calculator. So do you see there's patterns all over the shop? I'm hoping we get to the point today where we see a really good pattern. Now, this one would be 2x to the 20 take 20, which is 0. And you go, why did you really write that? Because what is anything to the power of 0? 1. So you probably didn't need that, but I'm just putting it in there to show the pattern, and it would be minus 3 over x to the 20. Is that making the sense? And of course, this one would then be 2x to the 20 take 19, which is 1, and minus 3 over x to the 19. Ooh, didn't really leave that much space there. So does that, you haven't done this, but does that make sense? It's sort of just following Pascal's triangle, and instead of us having to go, oh, let's write down all of the 1 through 3 all the way down to the 12th row, we use our combinations because they give us the answer. We okay with that? All right, so you will then have a little bit of a practice, but the rest of us, we're going to dive in. What was the question you had? 6? So there was 6 and 8. 6b and 8. So 6b, if you did it, you might wish to listen to say, hey, I did it an easier way, right? Or if you haven't done it, you're paying attention, but please, might sink and help things in. So we wanted to do b, was that correct? B. Now, it's asking us, find the coefficient of x cubed in the expansion of. So what we're first going to do is find our general term. Okay? And we go, yep, sure, we don't know what r is. Do we know what n is? What is n? Good. Do we know what our a is? 2x squared. So this is Friday last lesson. And so I'm going, my head hurts, something's shocking. I'm putting everything down. Oh, didn't we just use this one? Oh. Oh. Or was it 2? Oh, it's right above. See, told you, Friday. All right. Anyway, here we go. So we put in and we find our general term. Right? Here goes. So our general term will be what? Well, I like to go C. 6. We don't know what r is yet. That's what we're going to try and find. 2x squared. And then we're timesing by the b value. And that has to be to the, I missed that. I messed that up because you're talking and I was, you weren't talking, I was listening. That has to be to the 6 take r. And then we've got minus 3 over x, and that has to be, that has to be to the r. 2x squared. They're talking at me. Yelling. Deriv is yelling at me. All right. Now, we are after what? the coefficient of x cubed. The first thing we need to do really is find what r is to make x be x cubed. You go, why can't we just try and make it here? Well, you got a bit over there. So we are going to play with our exponents. Exponents, correct? What is the exponent? While we're here, I'm just going to keep this out the front, even though I'm not really fussed about it. So doing this with my year 10s at the moment, when you've got something in the bracket, you've got a power to a power, what happens? Right, two things. Everything in the bracket gets the power, and times the power. So it's going to be 2 to the 6 take r, not that that's going to feature in our things at the moment. And it's going to be 2 times 6 is 12. 2 times minus r is minus 2r. We happy with that so far? The next bit. What happens when you've got fractions? Yep, top and bottom get the power. So that's going to be minus 3 to the r all over x to the r. We good there? I am focusing on my x. So I'm even going to have a bit of a change of colour here, and I'm going to go, I've got x to the 12, take 2r, and I'm timesing, or technically you're dividing here, by x to the r. Do we agree? So what would be the power of x if you wanted to simplify that? Dividing by the same base, what do you do to the powers? You minus them. So this would be what? X to the, already, 12 minus 3 would be like some r. But what did we want the coefficient of x to be? 6. So we're saying, therefore, we want x 12. We want to equal x to the 3. Okay? With my year 10s, I go, ha ha! Because I've got the same base. If the bases equal each other, ha ha! That means the powers have to equal each other. So that then leads to another serious business now. I've got two therefores. Can we now solve that? 3 comes on the other side, we get 9, 3r goes on the other side, and therefore r is 3. How do we get the coefficient? Well, sub that back up here. Okay, the coefficient will then be, that'll be C6, 3. Where else did we have, oops, oh, that jumped dramatically. We had 2 to the 6 take r, but r is 3, so 2 to the 3, and then I reckon we had a minus 3 to the what? Sorry, it's jumping. Minus 3 to the r. So that'll be to the 3. Pop that in your calculator, and you've got your coefficient of x cubed. I like that question, but Laurie's is the best. Okay, so hopefully you practice. You should have stopped the video. Don't jump straight to 8. The people in the class have done question 1, 2, 3, all the way up to 7, and then they had a request for 8. So I'm just keeping this in the vid, but you don't look at this yet. Anyway, here we go. We've got what information? We've got the third term of this is 36x squared. Find n and hence the fourth. So I'm going, yeah, okay. Fourth term is coming. I'm just going to settle with the third term first. Now, if we go back to our Pascal, look at this. This was the first term, the second term, the third term. Remember, it's always one less. And we also know from here that it's going to be one less. So if I want the third term, that means r must be 2. Okay, so we are going to say, if I want the third term, we're going to start with C. C, senor. N. I better write it here. I'm going to write r equals 2. So we're going to start with the 2 there. Happy? Tom, you said you didn't do this one, so you're looking this way. What am I going to do next? Do I need to have your formula here? So you should have this in front of you. What comes next? A, which is your first term, and we're going to take that to n take r. Okay, what's my first term? Well, it's 1, and as much as I could write n take 2, I'll write n take 2. And deriv is going to say something in a minute. And then x, because that's the next one, what power do we take that to? So you go over back here, if you're unsure, what does it say? To r. So what's my r? 2. We? All right. So this thing here, what is 1 to the power of anything? 1. So therefore we've got cn2 x squared, and we want that to equal 36 x squared. In other words, we want cn2 to be 36. Oh dear. What am I going to do now? Pardon? Trial and error works nicely. Yeah, you've got beautiful graphic calculators that you could suss. So grab your calculators, put in 1, put in 2, put in 3. So yeah, that's about it really. So working your way through, I really like, and I forget some of these things, I tell you. Question 11, I really like it. But we could all even do part of that now. Could I ask you, so part of question 11 asks you to add up the rows of Pascal's triangle. Add it up. I'll use a different colour. What colour do I need? We'll go white. So we get 1. I need more room. We've got 1. What's 1 plus 1? What's 4? What do you think the next row will be? Yeah, it will be. What do you think the next row will be? So this is row 1. This is, oh, that's 0. That's row 1, right? This is row 2. This is row 3. So if I said what would be the nth row, what would they add up to? 2 to the power of n. If you notice, 2 squared is 4, 2 to the 1 is 2, 2 third row cubed is 8, and so on. So the nth row would be, they'd add up to be 2 to the n. It's very cute. Year 8s discover that when they just draw Pascal's triangle and they play with it. Well, I don't have year 8s anymore, but anyway.